Hello everyone. In this demo we're going to be looking at a Snowflake as a data platform from retail and marketing point of view. In retail and marketing, a lot of simple questions are asked, but they're not always easy to answer because the data is usually scattered across multiple domains and systems. Questions such as who bought cookies and how much, or what are the other products that are being purchased with cookies? How often are the cookie buyers visiting our website, or what do they think about our products or our company, and can we retain those customers if they're not happy? Again, these are simple questions, but they're difficult to answer because of the data. It's the size of the data, it's the format of the data, and it's the location of data that makes it difficult for analysts to be able to answer these questions quickly. In the next 15 minutes or so, we'll cover how we can use Snowflake's various data platform capabilities to walk you through providing an end-to-end solution to a retail and marketing use case. Just to cover the use case quickly, we have Twitter data, which provides customer happiness. We have sales orders coming from SAP. We have web feeds coming from our website in the form of JSON. And we also have product reviews. Again, it has free-form text data in them. The data is being stored at a data lake in different formats, such as semi-structured JSON and CSV. And the goal is to take all that data sets together, create a single source of truth, and provide and run additional tools and processes to enrich and create data models in the end for analysts to work with. Let's go ahead and connect to Snowflake to create the necessary database and tables for our demo. Okay, now that's done, let's go ahead and look at our first use case, which is data lakes. When it comes to data lakes, one of the biggest hurdles is giving direct access to the data that's stored within a lake to your end users. That's due to the volume and the numerous formats the data can be stored within a lake, plus the lack of actual speed when it comes to analyzing it. The typical solution is to throw in data marts into the picture with added cost, then pick only a limited set of data that's in your lake and replicate them multiple times into these marts for end user access. This not only adds cost, but also increases the complexity and the data governance issues, and not to mention the amount of time it takes to deliver the data to the business. So let me show you how we can address these issues using Snowflake's data lake capabilities. Again, when it comes to data lakes, Snowflake can play various roles. The first one is for existing data lakes to run merely as a query engine to analyze existing data that's in your lake. For this exercise, our goal is to find out every single order line item for cookies, which was previously impossible due to the summarized version of the data in a data mart. First, we'll use our instant elasticity to instantly create a virtual warehouse, which will provide the compute resources for our queries. Then we will query about 3 gigabytes or 207 million rows of CSV data sitting on an S3 data lake using Snowflake as the query engine. Let's go ahead and execute this simple query to see the results. You can immediately see we were able to spin up a virtual warehouse within less than a second. Now it's actually querying the data that's sitting on the S3 data lake. So we should have our answer within a few seconds. Again, going over 210 million plus rows and 3 gigs of data, and the query is finished about 8.4 seconds, and we can see the results. So using Snowflake as the query engine, we were able to provide our marketing department the entire detailed line item sales data using nothing but standard SQL compared to a summarized version of that that they had access to before, which lacked many of the important order attributes. We have seen how Snowflake can operate as a query engine on an existing data lake. Now let's see how Snowflake can be the data lake where data is accessed and stored within Snowflake. For this exercise, we'll actually ingest the same large CSV dataset into Snowflake along with some additional JSON datasets. To do this quickly, we'll instantly increase the warehouse size to a large, which will give us 8 times the compute power. Once data is ingested, we'll then shrink the warehouse to extra small, which was the size that was used for the initial query, and run the exact same query for the line items for cookies. Let's go ahead and start this process where it will run the exact same query against an internal data set. You can see within less than a second we were able to increase the warehouse size to large, which is 8 times the capacity, including 8 individual servers. Now the ingestion process started, and we were able to ingest 207 million rows in less than 17 seconds and immediately shrink the data warehouse size to extra small down to a single server. Now it's run on the query, and the exact same query finished in 1.7 seconds, returning the exact same data set. And the 1.7 second performance will only improve with each subsequent query because of the internal caching mechanism built into Snowflake. But wait, there's more. During the ingestion process, we also ingested detailed web usage data in raw JSON format. Again, because of the volume and the semi-structured format of the data, marketing only had summarized version of this web visits for their analysis. Now using Snowflake, not only we can ingest raw JSON or XML just like a data lake, but we can also query them directly as well using nothing but ANSI SQL. Let's go ahead and get this process started. It's querying the raw JSON data stored in Snowflake tables, and within 1.7 seconds we're able to get a nice columnar data set that we can use for our queries or other BI tools. As you can see, when Snowflake is used as a data lake, marketing gain access not only to the most granular line item sales data, but also the most detailed web usage data that was previously sitting as raw JSON in a traditional data lake and not being fully utilized. If we look at our results of Snowflake running as a query engine on top of a lake versus Snowflake as a data lake, there is a 5 times improvement in the performance when the data is stored within Snowflake. Again, this time of 1.7 seconds will only improve as users run more queries due to the caching mechanism built into the Snowflake. If you review what we have seen so far, initially we used Snowflake as a query engine on top of an existing data lake. Benefits were faster analytics, improved governance from end users, and users having to access more of the data that's in your lake. But you still have the higher cost, complexity, and the longer data delivery times associated with lakes. You also have not eliminated governance and security issues because multiple copies of the same data are stored on a file-based system with limited controls around data governance and security. Now, we could have gone one extra step and moved the data processing layer on the Snowflake as well. That would have added benefits of reducing data delivery times by increasing data processing efficiency and at the same time lowering your cost by Snowflake's scalable elastic compute capabilities. But instead, we went with Snowflake as the data lake instead. The results were faster analytics, instant secure access to all of your data, end-to-end data governance and security as a single copy of data is shared among various workloads, which data is secured by role-based access from the point of ingestion, and data is always encrypted at rest or in transit. This method also allows you to have the fastest way to deliver data without having to replicate or move your data sets. You also gain full set of Snowflake features such as zero clone copy and time travel, which I'll show you later as well. Next data platform use case is data engineering. Depending on the organization, data engineering can involve a number of steps from ingestion to data cleansing, transformation, movement, to all the way to delivering secured and governed data sets to businesses via data modeling. In our scenario, marketing department is requesting access to Twitter and web visit data in a manner where they're familiar with, which is using standard SQL. They also have a need to enrich the Twitter data with sentiment scores based on the tweet content and correlate that with sales and customer information. This is to identify at-risk customers based on various product groups and their sentiment of company and products. Let's see how a data engineer can handle this using Snowflake. Our first challenge is the web usage data is stored in Snowflake tables in raw JSON format. However, marketing wants it in a flat columnar table so that they can use their existing BI tools. Using nothing but standard SQL, our engineering can transform the JSON data and insert it into a new standard columnar table in a single process. As you can see, we can also perform some transformations during the step by replacing nulls with actual values, also by adding a calculated column to this data set. Let's go ahead and get this process started. As you can see, raw JSON format is converted into a nice columnar format, and data is inserted into a staging table. Let's go ahead and repeat this process for Twitter data as well, but instead of creating a table and inserting records, we'll just create a SQL view for this for marketing to use with their BI tools. For this step, first we'll create a SQL view using the underlying raw JSON Twitter data, and then we'll run a simple query against this view, simulating the way marketing can interact with this data set. Let's go ahead and kickstart it. The view is created and the query is executed. The result is a nice columnar data with tweet content, username, and the user location for marketing department to use within their analysis. The next data engineering request for marketing department was to enrich the Twitter and product reviews data sets with sentiment analysis. That's because the content of the Twitter and the product reviews is pretty much meaningless to marketing department unless there is a score attached to it. For the data enrichment step, we'll use Python machine learning and its sentiment analysis libraries to process our Twitter feeds as well as product reviews. We'll update each tweet and product review with a sentiment score ranging from a negative, neutral, or a positive for marketing department to use for their analysis. Let's go ahead and kickstart this process. Python will read each tweet and product review, run through sentiment analysis, assign a negative, positive, or neutral score along with a numerical score ranging from 1 to -1, and update each record for the marketing department. At this point, we have full access to entire sales details data, access to detailed web visits and e-commerce data. We also have access to tweets and third-party product reviews. On top of that, we can also tell what each tweet and product review means to our company as a numerical score that can be used by marketing and their BI tools. Now that our data engineer was able to prepare the data in development schema, the next step is to move the entire data set to production schema. Just to recap, our largest table is 3 gigs in size and 217 million rows. Now, this dev to prod move would be a time and resource consuming process and most likely be done in off hours, not to affect business users. This is not a problem with Snowflake, as we can instantly clone terabytes of data in seconds without affecting the business users creating the same set of data. Even though this will replicate the entire 217 million rows of data in production, it will not use any additional storage that will normally be associated with added costs within traditional platforms. It also uses minimal compute resources, if any, and finishes the job in seconds. In this case, it took about 1.7 seconds, saving not just a ton of money, but also a ton of time. Now you can easily see how this process alone can transform your data engineering cycles and allow you to deliver much more data at much rapid pace, allowing business users to make decisions based on near real-time data instead of stale data sets from hours or days ago. Our last step within data engineering is the data modeling. So this is the step where we create secure and governed data models for business users so they can use it within their BI tools. For this step, we will manually create secured and governed SQL views that join multiple data sets together for business users to consume. For this step, you can also use any standard SQL-based third-party tool as well. Let's kickstart this, and our production views are created for analysts. The next use case in a data platform is data warehousing, which Snowflake was founded on. Traditionally, data warehouses were limited by compute and storage resources, hence the amount of data, the number of users, and sometimes even when those users have access to data warehouse was limited. But with Snowflake, none of those limitations exist, as we can handle any volume of data with any user concurrency and any query complexity using our elastic and scalable compute and storage layers. For this exercise, we'll have a marketing analyst execute a complex market basket analysis query against a 200+ million line items to find the top products that are purchased together along with cookies. System will simply aggregate the data by invoice numbers that contain cookies and find other products that were purchased as part of the same order. Again, these type of queries are both time and resource intensive, and they're typically run as a batch process during off hours to provide recommendations for customers that purchase similar items. But for Snowflake, complexity and concurrency is no longer an issue because of our instantly scalable virtual warehouses. So for this exercise, we'll increase our virtual warehouse size to large, which will give us 8 times the capacity, and finish our queries much faster without affecting other users that are querying the same data set. Let's start it. You can see virtual warehouse was scaled up to large with 8 servers in less than a second. Now run a query, complex query against 200 million rows of data, and it should come up with the answer fairly soon. And here we go, within less than 13 seconds we're able to get answers to our cookies question. So these are the products that were most commonly purchased with cookies: a jumbo bag with 50 pieces of cookies, oddly enough have to lose 10 pounds in 10 days, along with cookies 756 times. Again, using the power of Snowflake's elastic compute and storage, our marketing team was able to get answers to their complex questions using our virtual warehouse. Another common use case within a data platform is the use of data science. For this exercise, our marketing department is trying to automatically segment and categorize at-risk customers who previously purchased cookies from us based on their tweet sentiments, which we were able to capture earlier, and their lifetime value, which is part of the invoice data. This data will be used automatically to engage with at-risk customers to send promotions in order to keep them with our brand. To perform customer segmentation, we'll use Snowflake and Python's machine learning data clustering libraries. Snowflake will join both sales orders and Twitter feeds data sets together and aggregate them by customer ID, lifetime value, and Twitter sentiment. And then this data will be sent to Python for analysis and clustering, and we'll see the results shortly. Let's start it. Right now, Snowflake is summarizing data with 4 servers. Data is summarized based on machine learning algorithm. We end up with 4 segments of customers based on the customer's lifetime value, as well as their Twitter sentiment of our products and company. Our next data science related challenge is to be able to correlate purchasing data with e-commerce web visit data in order to come up with a web visit forecast of customers who previously purchased cookies from us for the next 7 days. This will be used again by marketing department for their upcoming online promotion involving cookies. Let's start it. Snowflake is summarizing data by web visit date, number of visits versus number of customers who purchase cookies, and comes up with a 7-day forecast. The data with dots, black dots, are actual data. Any portion after the dotted lines is the forecast that's coming out of machine learning algorithm. So this forecast in turn can be used by marketing to further tweak their next upcoming online promotion. Now at this point, I covered most common data platform use cases and challenges and how they can easily be solved by using Snowflake's data platform, and doing each one faster, easier, and cheaper than any other traditional method out there. Our last step is to show you how marketing users may interact with this final data by showing you how PowerBI can access this 200 million row dataset in a live direct query method. Here we're looking at a pretty standard dashboard that a marketing may look at, which is analyzing sales orders, sales data, along with the web usage data using the data models we created from our earlier steps. The Power BI is actually looking at the live data set. You can see the total count is 200 million rows of data with $4.6 billion in sales. Let's go ahead and select only the female customers using the donut chart from our dashboard. Just clicking on the female gender will automatically send queries to Snowflake from 218 million rows down to 78 million rows within a few seconds. So from there, we'll pick a a single customer name, one of our top customers. Again, now we're going from 78 million rows down to 168,000 orders. Now this is a scatter plot of total sales versus quantity. Maybe we'll pick just one product that this person purchased. So now that we selected this product, Snowflake is querying the data. Now we're down to 2,700 rows of data. Again, from 280 million rows of data to 2,681 rows within few seconds, using Snowflake as a backend database or data warehouse. As you can see, you can easily use Snowflake to roll out large volumes of data to self-service BI user groups. With traditional warehouses, these users were either limited to smaller sets of data, or they would have to download data sets locally on PowerBI dashboards or Tableau dashboards. From there, we jump to Web Visit dashboard, looking at data from data models from data engineering side. Again, we can easily interact with data in real time, just picking the online orders, seeing the history of the web visits versus page views, maybe pick a couple of web pages or online promotions to see the trend line change. Also be able to see where the customers are coming from on a map. And that's it. This is in a nutshell how Snowflake Data Platform can accelerate your analytics, reduce your time to insights, and increase your security and governance while lowering the costs and reducing complexity at the same time.